Hey, hello and welcome to today's GFG problem. The day hope you're doing well. So let's see today's problem. Move all zeros to end. Okay. So this is an easy category problem. I'll also make it very easy for you. But just one request to please subscribe to the channel, like the video, comment on the video, because at the end of the day, your subscriptions motivate me to create videos for you. Okay. Thank you so much. So let's see quickly what the problem is. So we'll be given an array. What we want to do is we want to push all the zeros of the given array to the right end of the array while maintaining the order of non-zero elements. Do the mentioned change in the array in place. Array in place in this sense, they are saying that we want to do this operation, right? Into the same array, into the same array. Okay. So first of all, let's quickly see the naive approach. Okay. So in the naive approach, what we can do is we can take an extra array of the same size of the original array. Okay. We'll take an extra array and we'll have a J pointer. Okay. So what the problem is saying is we want to move all the zeros, right? We want to move all the zeros, okay, to the end of the array. Okay. What does that mean? Like, how does it look? So for example, let's quickly see like how it will look, right? So simple. All the non-zero elements, they need to be at on the left side in the same order. Okay, followed by the zeros. Okay, followed by the zeros. So this is the expectation. Okay, this is the expectation. Now let's quickly see how can we solve. Let's come back to the to our naive solution, right? How can we solve with the extra space, right? So we are taking an extra array of the same size as the original array, right? As the original array. So now we'll start. We have a J pointer here and we'll check. First of all, we are going to check whether it is a non-zero element. Yes, it is a non-zero element. So we are going to check for the non-zero elements and we are going to place, okay, into the new array. So here we place a new element. Okay, we increment J. We check, is it a non-zero element? Yes, it is non-zero element. We place the 2, okay, at jth position and we increment J, right? Here it is a 0. We ignore it. Okay, we ignore it. Let's go to the next element. Here we come across 4. Okay, so there's a non-zero element we have found. So we are going to add, right? And simple, we are going to increment J. Again, same non-zero element. Okay, 0, ignore 5. Okay, uh, uh, okay, place 5 at jth position and increment J. Okay, and increment J here. So J is here. We have also exhausted the the iteration, right? The iteration of the array. We are done with the iteration of the array. Now, what we are simply going to do? We are going to check if j is still less than n. While j is still less than n, okay, while j is still less than n, keep on adding, keep on adding the zeros. Don't look for the zeros here, how many zeros are here. Keep on adding zeros until j is less than n. Okay, okay, so this is the solution. Okay, this is the solution. So once we have all the zeros at the right side of the array. Okay, so what we're going to do now, we are going to now modify the original array. Just copy the elements of the, just copy the elements, right, of the element, just copy the elements in the temporary array, in the new array. Okay, sorry, just copy the elements from the temporary array to the original array. Okay, and we are done with this. Okay, but here what will be the what will be the time complexity is going to be O of n only, but the space complexity will require is O of n, which is extra space. So can we solve this using no extra space, right? Using no extra space. So let's quickly see. Okay, so what I want to do here is, so we won't take extra space as I told, right? So here we will take, let's say, a jth variable, okay, and an yeah, and let's take here ith variable and jth variable here. Okay, jth variable here. So jth index, it is for tracking of the non-zero elements. Okay, and ith index is to iterate the elements, all the elements of the array. Okay, so here we are going to check again for the non-zero elements only. For the non-zero elements only, is it non-zero element? Yes, it is non-zero element. So just swap with I and j. Just swap. Okay, okay, whatever is at j with I. So here it, since both I and j are pointing at same, so it is going to be 1 only. Okay, and what are we going to do? We are also going to increment our j and we'll increment our I as well. Okay, I as well. So here again we are going to check, is it non-zero? Yes, it is non-zero. Just swap the arrow of I and arrow of j. Since both are pointing at the same location, right? So it is going to be the same. So we'll increment j again and I again, right? Here it is non-zero. Okay, here it is non-zero. So we won't do anything. We'll simply increment our I. Okay, j will be as is. We'll simply increment our I. Now here we found a non-zero element. So now we are going to swap with the element at jth location, right? The element at jth location. So it is going to be what? It will be now 4 and this will be 0 now after swapping, right? After swapping, it will be 0 and here it will be 4. And we'll increment our j. Okay, we'll increment our j and also our I. So as I told, right? So J is the index for or the pointer for tracking the non-zero elements, right? So here again we found non-zero element 3. So J is pointing here and I is pointing here. So we are going to swap. Okay. So 3 will be here, right? 3 will be here and 0 will be here. And 0 will be here. We'll increment J and I as well. Okay, I as well. So here since I add of I it is 0, we are going to ignore this. Okay, we are going to ignore this and we will move ahead. Again, we found a non-zero element. So we're going to swap with the element at jth position, right? So here it will be 5, right? J is here. Here it will be 5 and here it will be 0. Okay, and J will be incremented. J will be incremented. Okay, and again we'll update our I, increment our I, and we're going to check is it non-zero element? No, it is not non-zero element. So we'll go ahead, right? And hence we are done with the iteration. And also if you see what is the state of the final array? So it is this 1, 2, 4, 3, 5, and all zeros placed at the end, right? All zeros placed at the end. So we didn't require uh, like extra space, right? So with this intuition, with this approach, we were able to solve this problem in complexity O of n and without any extra space, that is O of 1. Okay, so I hope you have got the intuition. Now let's code. Okay, so you'll understand better. Before going to the code, I'll also request you to please subscribe to the channel, like the video. Okay, let's quickly see. So now Java and C++ code both are same. Okay, so I'll just show the Java code. Okay, yeah, and also I like there's minor change in both C++ and Java code. Okay, I'll attach the code in the comment section. Okay, so let's code it I equal to 0, I less than add dot length plus I. Okay, and we'll also have our j and j equal to 0. Right, now we're going to check it. If if it is non-zero, then what are we going to do? Just swap add of I add of j, whatever is at j, and add of j tab. Okay, and here we are going to increment a j also, right? So this is it. This is a solution, right? This is a solution. So I have already explained I mean we have done the dry run, right? So I hope you have got the solution. Um, let's quickly submit this, compile this. So we are only going to increment j, okay, when we have found a non-zero element. And here, whenever we found non-zero element, we ignore the zero element, right? And whenever we found the non-zero element, we swap with the element at j, whatever is there at the ith position. Okay, let's submit it. Okay, the test cases are processed. Thanks for watching. Please subscribe to the channel, like the video. Let's quickly see the C++ code. Only minor changes, add of size here. That's it. Rest all the code is same. Okay. Thanks for watching. I'll also attach the code in the comment section. Please subscribe to the channel, like the video. Have a happy, healthy, and a great day. Thank you so much.